Good evening, everybody. My name is Victoria Drave from Year 11, and the only reason why I'm giving this talk to you right now is because I love astronomy. Now, some of you may be wondering why I chose to talk about astronomy instead of literally anything else. So let me start off with a little bit of a story about how I was inspired. Now, let me just say, my inspiration came from when one of my best friends entered my life. It warmed my heart that there was someone who would appreciate the things that I loved and the things that I was interested in. And it was wonderful that they shared the same kind of passion. So like how we questioned why the universe could expand faster than the speed of light, or why Mars could be habitable at some point if we made giant air purifiers everywhere, or a machine that could rearrange the atoms of one thing to make something else. And these crazy, stupid ideas were what made me so inspired. And then came my interest in stuff like constellations and black holes and white holes and wormholes, and now I'm here. So thank you, Jake, wherever you're watching this from. But apart from my inspiration, I would like to start my talk out with a question. Where do we go now? It may sound like a very vague question, but actually it's been asked for thousands of years now. Humans are a nomadic species, which means we love to explore. And even if it's on Earth or in space, where do we go now? Now, before everyone hits a wall of existential anxiety, I'll ask another question. Have any of you heard of exoplanets or super-Earths before? Because before I found an article on it online, I never knew they even existed. So here up on the board are some, a planet which orbits a star outside the solar system is what an exoplanet is, and a super-Earth is an exoplanet with a higher mass than Earth. Now, I'm proposing this because of one thing, the destruction of Earth. Some of you may say, oh, we've heard all of that before, how humans destroy the environment, blah-de-blah-de-blah. But worldwide, we are in over $217 trillion of debt before we realized we could even be in debt because we print all of our own money. So, well, what do I want to talk about? I believe traveling to space might save humanity. There were some solutions that we could consider, like efficient energy use and eradicating fossil fuels like natural gas. But I feel like our funds are better put trying to save what's left of the Earth, but also to find some other planets, or at least learning from what we can find in the universe. So there will be a couple of planets. Some people say, why should I care? I'll be dead by the time that the Earth is inevitably destroyed. But would you rather do nothing and let future generations suffer for what we could have done, or would you rather do something now and maybe improve the Earth? So there are 3 exoplanets I will be talking about today, and it's okay, you guys don't have to remember the names. And Mars, 55 Cancri E, Ross 128b, Kepler 452b, and Mars. So now in my very unsuspicious Tupperware box, I have made models, at least models to about as specific as I could make them without being to scale. And I will bring these out as I introduce them. The first planet, or exoplanet, is 55 Cancri E. Also known as Janssen, it's 40 light years away in the constellation Cancer, which is why its name is Cancri. It was discovered in 2004 and is about twice the diameter of Earth and 8.63 Earth masses. And why is this important? Because of its atmosphere. In its atmosphere, it has hydrogen, helium, nitrogen, and oxygen, and though we don't have hydrogen in our atmosphere, it's got the most closest we can find. But this is what it actually is. 55 Cancri E is a floating ball of lava in space. With surface temperatures up to 1,300 degrees, we will never be able to live. So what do we have to learn from this? It's a lot harder to find suitable planets than we seem to see. The next one I'll be talking about is Ross 128b. And this multicolored planet is quite special. 11 light years away, tucked in the constellation Virgo, this tiny planet orbits a quiet star. It was discovered by American astronomer Frank Elmore Ross in 1926 and is quite similar to how big the Earth is. Why is this important? Because of its surface temperature. Stable at about -60 to -20 degrees, it is about as cold as some parts of Russia. But there are many factors we need to come into play when thinking about where we can live. The last exoplanet I'll be talking about is Kepler 452b. And why is this important? Because it is the closest Earth twin that NASA has ever found in its Kepler project, which was started in 2009. It's said to live in a solar system where water could exist and seems to be riddled with active volcanoes. But the problem? It's 1,402 light years away. So let me step back from all this facts and figures and try and get some actual stuff into play, because maybe light years doesn't sound like a lot. Because if you say 1,402 centimeters, it doesn't sound like a lot, or kilometers, or miles. But can I ask for a couple volunteers, please? Okay. Wait, no. We have enough people. You can stand in the back. Okay, I'm going to need my trusty meter ruler. The thing with this meter ruler is that every centimeter is a light year. So maybe we can put this more into perspective. Guys, can you stand like together, because Mars and Earth are not anything apart.
Do you want us to move a little further?
Please move.
Sammy, we need to move it further that way here. Okay, get really close together. And
Okay, this is Ross, which
you
is
want me to
11. So you are here. You can stand where I'm standing, please.
okay.
You're this one. And Jacqueline, can you stand where I'm standing, please? Great. And to put this into perspective, this is how far Ross 128 would be. It is still not enough space. I would need 14 meter rulers if every centimeter was a light year. Thank you, everybody. Please put them back on the ground. I don't know where my Tupperware box went, but
Someone grabbed it.
the point is, even if we do find a habitable planet just like Kepler, it would take thousands of years not only for us to get there, but maybe for our technology to catch up to how far it would take us. So the last thing I'll talk about is Mars. And to be honest, I feel that Mars is an absolute miracle. Why? Because just in January this year, water was found under the layers of sand in Mars's surface. Oh, whoops. January 11th, 2018, new NASA images show layers of ice peeking out of eroded cliffs, a potential boon for future humans on the red planet. And obviously, this is a big deal. It's a really, really big deal. But the problem is, even if it's really close to us and it only takes a couple months to get there, its atmosphere consists of 95% being carbon dioxide, the only thing we can't actually breathe. So I want to give a couple questions to everyone. What kind of solutions do we have? If we are going to move away from this, where will we go? We need to cherish what we have, because this is all we have. Out of 60 million planets that NASA has found over the course of its Kepler project, only one can have and support our human life. Only one. And we're on it right now. If we destroy everything we have, where can we go if 60 million is not enough in our habitable zone? And do you think we'll ever truly find somewhere as habitable. But, as Stephen Hawking said, it's not much of a universe if it doesn't house the people that you love. Rest in peace, and thank you, everybody.